Hello class, these are our notes for sections 7.6 and 7.7. We are rewriting quadratic expressions in factored form. This is parts 1 and 2. So we're going to start out by multiplying some binomials. So let's go ahead and multiply. We're thinking about that FOIL pattern where we multiply the first and then the outer and then the inner and then the last. Let me see if I can get my pen going here. So x times x times 7. So x squared plus 7x minus 2x, and then negative 2 times 7 is minus 14. You can go ahead and just pause the video and try these on your own, and then go back and check your answers. So hopefully you got all 4 of them right. We're now going to go through and see if we can find some patterns. So I want to look at my finished expansion here, right, where I've got my x squared plus 5x minus 14, and I want to look at the negative 14 and at the 5x and see if I can figure out how to get those numbers from just the negative 2 and the 7. So what I'm hoping that you see is that negative 14 is always, it's those two numbers being multiplied. So the negative 2 times 7 is where I get the negative 14 from. So this last term is always those two numbers multiplied. Now the middle term, on the other hand, if I think about what happened there, I had 7x minus 2x. So the middle term I got by combining the 7 and the negative 2, by adding those together. So that's from negative 2 plus 7, or 7 plus negative 2. Let's see if this pattern holds on the next one. So in the next one, when I look at the 45, that comes from multiplying my 5 times 9. And if I look at my middle term, I get that by adding the 5 and the 9. And that makes sense because I had a 9x and a 5x and I added them together. So obviously there's also an x here, right? But we're looking at just that coefficient. Where does the coefficient come from? On the next row, let's see if our pattern continues to hold. You know what? I multiplied something wrong here. This should be a minus 16 instead of a minus 18. And we do in fact get that by multiplying negative 8 times 2. And then by adding negative 8 and 2, we get our middle term. That still doesn't look like 16. Let's go ahead and fix it. And this is why we check answers, right? My very last one, let's see if it works again. We have negative 6 times negative 3, so negative times negative makes a positive 18. But when I add two negatives, I get negative 6 and negative 3, so 6 plus 3 is 9, but now it's a negative 9. So that pattern holds all the way through. So we're going to work on using this pattern today to work backwards. So I am going to start out with a trinomial, and then I want to rewrite it in the factored form. So my trick is going to be finding these two numbers. In this case, like the 8 and the negative 2, I want to find those two numbers so that I can write x minus 8, x plus 2, and I can write it in factored form. So the way we're going to do this is we're going to look at our last term. So I'm looking at the 4, I'm looking at the constant term, and I'm trying to think about numbers that multiply to make 4. So 4 is 4 times 1. It could also be 2 times 2. I want to look at those and I want to think about which of those combinations could I add together to get the 5. So would I get that by adding 4 and 1 or by adding 2 and 2? And so 4 and 1 is the one that works. So 4 plus 1 makes 5, but 4 times 1 equals 4. So I'm going to factor this as x plus 4 times x plus 1. And then if I go through and check, we could go through and we could double check it and make sure it works. So if I go ahead and multiply this out, I would have an x squared plus a 1x plus a 4x plus a 4. So that's going to be x squared plus 5x plus 5. which is back to what I started with. So I know I've factored it correctly. So my answer is going to be x plus 4 times x plus 1. I'm not going to multiply them all back, but I think it's good for you to see that. So on the next one, I want to look for two things that multiply to make negative 35, but add to make a positive 2. So if they need to multiply to make a negative, I need to have one negative and one positive. But if I want to add to make a positive 2, my bigger number needs to be positive. So if I think about how negative 35 is 35 times 1, I would need to be looking at, in order to add and make a positive, the bigger number being positive. So I'd make the 35 the positive and the 1 the negative. It could also be 7 times 5. So the bigger number, the 7, should be the positive, the 5 should be the negative. So now I want to think about adding them. Well, 35 plus negative 1 makes 34. That's not going to work. But 7 plus negative 5, that would work. That would make a positive 2. So that means I'm going to have x plus 7 times x minus 5. So on our next row, we have negative 10 as our last term, and I want to add to make a negative. This means this time my bigger number is negative. So it could be a negative 10 times a 1 or a negative 5 times 2. So which of those adds to make negative 3? Well, that's going to be the negative 5 and 2. So x minus 5 times x plus 2. So I really hope that you're trying to maybe work ahead. You could certainly pause, but you really need to just practice some of this on your own. If you're struggling with what multiplies to make a number like 8, it might help to use a multiplication table. But this is really something where you've got to have some strong math facts. For number 8, I need to find two negatives that multiply to make a positive 8, but add to make a negative. That means they both need to be negative. So I could write negative 2 times negative 4 or negative 1 times negative 8. So the 2 and 4 would add to make 6. So I'm going to factor it as x minus 2 times x minus 4. In the next row, multiplies to make 12, adds to make 8. So 12 could be 12 and 1. It could be 2 and 6. It could be 3 and 4. So 2 and 6 is the one that adds to make a positive 8. So we would make this x plus 2 times x plus 6. Factoring is one of these skills that we need to be really fluent at. We're going to use it all the time in math later on. And so we really need to get to the point where we've done enough practice that we can just kind of look at something and we can factor it quickly. The next one, I want a positive 12. It has to multiply to make a positive 12, add to make a negative 7. So negative 12 times negative 1, it has to be two negatives. Negative 2 times negative 6, or negative 3 times negative 4. So 3 and 4 would be the combination that adds to make 7. So this will be x minus 3 times x minus 4. On my next row, let's see, multiplies to make negative 16. They add to make a negative, so my bigger number should be negative. So negative 16 times 1, negative 8 times 2, or negative 4 times 4. So the negative 8 and the 2 add to make negative 6. So it's going to factor to x minus 8 times x plus 2. For the last one, x squared plus 1x minus 12. So I've got to multiply to make something negative, but add to make a positive. That means my bigger number needs to be positive. So 12 times negative 1, that's not going to work. 6 times negative 2, or 4 times negative 3. So 4 times negative 3 would add to make a 1. So this is going to be an x plus 4 times an x minus 3. For my last page, I've got some kind of tricky ones where we're going to have to do more thinking. So the first one's factoring, and I think what's tricky about this is I have both an x squared and a y squared. So for now, let's just consider x squared plus 8x minus 65. Let's look at factoring that. This would mean I would need things that multiply to make a negative 65, but add to make an 8. So 65 could be, let's see, it could be 65 times negative 1. I don't know what else divides into 65 except 5, right? And if I use a calculator to double check, or if I just do some long division really quick, 65 divided by 5 is 13. So because 13 is a prime number, these are my only two combinations, 65 and -1 or 13 and -5. And I've made the larger number the positive because they have to add to make a positive. So I can see that 13 and -5 is going to be my answer. This is going to be x plus 13 times x minus 5. So the problem is I don't just want numbers here, right? I need to have a y squared at the end. So the way to get a y squared is to multiply a y times a y. So let's go ahead and I'm going to write x plus 13y, and then I'm going to write x minus 5y. And let's look at what happens when we multiply this out. So x times x is x squared. X times minus 5y is minus 5xy. 13y times x is plus 13xy. 13y times a minus 5y is minus 65y squared. So my two middle terms are xy. I can combine those together and I get a plus 8xy. And then my last term, of course, is a negative 65y squared. So I really think that factoring something like this is a little bit tricky, and you kind of need to see it the first time and then, like we did, go through and multiply it back out to believe it really works. So by having an x squared at the first term in each binomial and a y in the second term with each binomial, we get an x squared and a y squared at either end, and we get the xy part in the middle. The next one is asking us to solve an equation. So we're going to do that by combining our factoring with our zero product property. So to solve, if I have an x squared, I need to be able to use zero product property. So I need this to be equal to 0 instead of 28. So I'm going to have to subtract 28 on both sides. Sorry about that. We just made it really big. So minus 28 minus 28. Now I have x squared minus 3x minus 28 is equal to 0. So in order to solve a quadratic, I have to factor it and use zero product property. So make equal 0. 2 is factor. And third is zero product property. So ZPP for zero product property. To factor it, I want to think about what multiplies to make a negative 28 and adds to make a negative 3. That means my bigger number is going to have to be negative. So I am going to think about how 28 is a negative 28 times a 1, a negative 14 times a 2, or a negative 7 times 4. So of these three, negative 7 and 4 would add to make negative 3. So I'm going to factor this as x minus 7 times x plus 4 equals 0. Now I'm going to go ahead and use my zero product property. Zero product property says if I multiply two things and they equal 0, each of them must equal 0 separately. X minus 7 equals 0. X plus 4 equals 0. And then we're going to go ahead and solve. So either my x is 7 or my x is negative 4 or both. It would be weird, x to equal two different things, but in the case of x-intercepts it makes sense. And so we've solved. All right, the next one is asking me to find zeros. So finding zeros is a fancy way of saying let your f of x equal 0 and find the values of x that make it so. This would be the same thing as x-intercepts. So let's go ahead and put a 0 in. And I have a negative x squared and a plus 14x and a plus 51. So what's tricky about this is this negative x squared would make the factoring very difficult. All of this factoring stuff that I've learned is when my x squared is positive. So I'm going to go ahead and I'm going to kind of do a little trick here where I add x squared on both sides. I'm going to subtract 14x on both sides. And I'm going to subtract 51 on both sides. And now I would have x squared minus 14x minus 51 is equal to 0. So now my x squared is positive, it's still equal to 0, and I can do my other steps. So I made it equal to 0. Now I'm going to factor and use zero product property. So 51, things that multiply to make negative 51 add to make negative 14. That would be, let's see, a negative 51 times 1. And I happen to know I can divide it by 3, so it could be negative 17 times 3. So of these two combinations, negative 17 and 3 is the one that adds to make negative 14. So this is going to be an x minus 17 times an x plus 3 is equal to 0. And then we're going to go ahead and solve with zero product property. So at least one of these factors has to equal 0. So we're going to make the x minus 17 equal 0 and solve. And we're going to make the x plus 3 equal to 0 and solve. All right, so main ideas today. The big main idea is this idea that we can factor, and hopefully you understand how that pattern works from multiplying. So factoring is our main idea for today. And then remember, we want to extend that idea of factoring into being able to solve more equations. So not only do I need to know how to factor, but we also need to know how to do something like this where we're solving an equation by doing those steps, by making it equal to 0, by factoring, and by using zero product property. So we're putting skills together from different sections. As always, class, if you need help, please make sure you ask.